All right. Well, I'm excited to be here with my co-presenters today to talk about analysis results data sets and how we can use these ARDs, which are part of an emerging CDISC standard that's coming for all of us in the pharmaceutical industry, to have our work be super reproducible, automatable, and also have beautiful outputs supported by this nice ARD format. Um, we will be sending a link to the chat for this website. This is our little conference website here, and it will be handy to have on hand throughout the workshop. So I'm going to click through this website to kind of show you what it is. So it's just here's a brief description of our workshop, our schedule. Our workshop's broken into four parts, kind of an introduction to ARDs in general, and then some extras, and then building tables with GT summary, and then building tables with T format. You can see bios about our myself and my co-instructors here. On the left are the exercises, which you may or may you can link to here, but you can also link to via Posit Cloud. And let's just get started. All right, so who are we? My name is Daniel Sjoberg, and I am a data scientist at Genentech. I joined last year from many years previous in academia, and so I am delighted to be here with you all and talking about programming and talking about doing really high quality work. Um, and I love it. So I love writing packages as well, and I love the R ecosystem. Becca, do you want to introduce yourself as well?
Sure. Hey, everybody. Thanks for being here. My name is Becca Krouse. I work at GSK as a data scientist in we have an internal innovation team. So a big focus of mine is creating tools in R packages, Shiny apps to help with the clinical reporting pipeline. Before GSK, I was a statistician turned data scientist at a CRO. So yeah, I'm been loving GSK and having a lot of fun building tools.
And Jack, would you like to introduce yourself to everyone?
Yes, thanks, Daniel. So I'm Jack Tallboys. I'm a software developer at Novartis. I'm fairly recent in the role. I joined about 6 months ago, and I'm part of the open source enablement team. So helping study teams to use R, building tools for them, offering support whenever they need it. Before that, I was a data scientist consultant, so building R packages or Shiny apps for kind of a range of different sectors. But yeah, sort of recently been kind of working with Daniel and Becca a bit on the cards package. So yeah, looking forward to this workshop, and any questions in the chat, I'm happy to help out. So let me know.
All right, thanks, Jack. Thanks, Becca. So, yeah, like Jack just mentioned, throughout this presentation and workshop, we're going to be stopping periodically to do some exercises. There's a break halfway through as well. But anytime you can definitely drop questions into the chat, and whomever is not presenting will be monitoring the chat to answer those questions. And if needed, we can interrupt and have a discussion with everyone as well. So keep the questions coming. That's how to make it the best experience for everyone. So what are we going to do today? We are going to first kind of give you an overview of the CDISC's emerging standard called Analysis Results Standard. So, and ARDs are a part of that standard. And those ARDs are going to be implemented with the cards package and with the card X package. So cards is going to give you your bread and butter stuff, and card X is going to be some extras, more complex statistical methods and some other things there. Then for the second half of the workshop, we're going to move into creating output displays from ARDs. And so we're going to begin with GT summary and end with T format. And with that, Becca, would you like to get us started?
Sure. All right.
Looks great.
Okay. All right. So we did this a little bit. All right. So getting into our plans for this workshop, our goals for this workshop. We think this workshop may be for you if you want to learn more about ARDs or want to learn about tools for working with ARDs, maybe making displays from ARDs. We aim to cover those things at least at a high level, and then kind of give you the knowledge you can take from here to do more and explore more. We do have some hands-on exercises. So if you choose to do those, you can definitely be doing some hands-on stuff and learning that way. So some expectation setting. If you find a bug, I mean, you're working with tools that they've been on CRAN a little while. GT Summary's been on there for a long time. T format a couple of years. Cards and CardX a little bit newer. But yeah, this is kind of the latest and greatest of the ARD tooling. So if you find a bug or something you're not sure if it's what you would expect, you can definitely feel free to ask questions, and that's the next bullet point. Ask a question in the chat. We will be giving links to the GitHub repository, so we always welcome people to file issues there. So that's kind of the best way to report any unexpected issues or feature requests even. That would be in the GitHub issues. But yeah, definitely in the chat, let us know if you need help. With one person speaking, we'll have two other people who are kind of trying to follow along if people are encountering any issues, and we'll try to help you out. And then the terms and conditions of R and Pharma, of course, there's a link to those. So we just ask you to be respectful. And, I think this is, maybe Harvey mentioned this up front, chat is the way to communicate. We don't have the ability for people to come on and off mute super easily. So, we don't have that piece, but definitely be respectful in the chat and ask your questions there. So we want to know a little bit more about you all. So I do have a Slido, and here's the information about the Slido. You just go to slido.com, enter this code, and I'll give you a minute before I start up the first question, and we'll just kind of get a sense of who's here and what's everyone's background. So I'll start the first question. And you can, the link and the information to join will stay on the left if you are taking a little bit of time to get there. But we want to know, what would you like to take away from this training? What are you wanting to learn today? Knowledge is good. And I can't see anymore, but how many people are in here? Daniel, can you see?
Yeah, we've got just over 50 at the moment.
Okay, cool. Nuggets. ARDs.
I'm glad to see people are interested in ARDs at the ARD
Right
workshop. You're in the right spot. This is good news
yes.
for everyone.
See some typing still. Knowledge, nice. All right, I'm going to move on to the next question. Which company do you work for? If you feel comfortable sharing, go ahead and put that in the chat or in the response. Good variety. I don't know how many people it takes to pop up in green like that. Wonderful. I think the next question is quite similar. What's your background? Pharma, medical devices, small pharma, biotech, CRO, academia, other? Do I have other? Yeah. Yeah, all right. So good distribution here, different folks from different areas in the industry. Curious which country you reside in. I think this time of day, it may be getting late for some folks. But we have someone from India, so. It's always cool to see. Nice. All right. And then how would you assess your art skills? I think, we'll have a lot of code that we're showing in, sorry, not a lot of code, like long code, but little code throughout, right? We're having a lot of examples in this. But most of it is focused on the specific packages. So in general, doesn't require a ton of R knowledge, right? But if you're newer to R, you'll have the ability to practice and run some examples for sure. All right, so I'm going to go ahead and stop the poll now. And I'm going to flip over to back to our content for our workshop here. So thanks everybody for sharing a little bit about yourself and where you're from and what you've been up to. All right, so a little bit more about the working environment. We do have, this should say Posit Cloud. We'll be working in Posit Cloud, where we've set up the workspace for you. So all you need to do is copy it, and we will put the link for that in the chat. It's not needed quite yet, but if you wanted to try and get that set up, you're definitely welcome. That does require you to have a Posit Cloud account. So if you don't have a Posit Cloud account, you'll need to create one very quickly using your email address. And then from there, once you have the account, you'll be able to join the space. So we'll share that link. You can also opt to just run stuff in your local R setup. We have everything available on our website. So really it's up to you. If you prefer to install the packages yourself and work in our studio, that's totally fine. And then from here, everything's going to be, and it will continue to be on the website and in GitHub. So you'll be able to access things after if you want to review the material or share it. So quick warm up, just to all sure that you can access whatever you want to access. Now go ahead and navigate. If you're using Posit Cloud, if that's what you want to do, we'll put the Posit Cloud link in the chat and you can go there. It'll show you the assignment. You'll see that will kind of be the only thing in the space. You'll just click on the hyperlink and it'll make you a personal copy of that space. If you want to use your local R setup, you can find the exercises on the website. In any case, the warm-up will be opening this file, which is actually 00 warm-up, but open within the subfolder called exercises, go to a file 00 warmup.r, and it's just a little exercise that you can run some code and get your brain working a little bit set up. But just a real quick solution for you. The warm-up was just within ADSL subsetting to the safety population, calculating the number of unique subjects in each treatment group. So just a little tidyverse exercise, and we see our big ends here. All right, some frozen. Okay. I'm going to move on to the analysis results standard and get going here. All right, so analysis results standard is it's something it's a standard being developed by CDISC, And it's quite far along now, but it's still in progress, I would say. And in the past, CDISC has put out a lot of information and standards that have been widely adopted, covering data collection, data transformation, but kind of stopping before results. And so the ARS is meant to fill that gap and cover the results as well, so that we have standards for how we define results, how we store results. So that is what the ARS is covering, and particularly it's leveraging metadata to drive the automation of results and supporting storage, access, processing, traceability, and reproducibility of those results. So your whole statistical analysis. Here's some information that I think is good reference for later, but what I want to say to this, generally, is the ARS is about defining all of your plans for analysis in advance and in a modular way. And it's very focused on metadata to, again, drive the automation of the pipeline. I think this is a nice diagram that shows the main components of the ARS, all the things that you might want to define in the analysis pipeline, starting with the study planning, the analysis populations, through which analyses you plan to do, what kind of computations you're going to do, and what displays you aim to make, all of that being defined up front. And yeah, the ARS is meant to define this infrastructure. Now, it's infrastructure, but the actual mechanism for doing a statistical analysis, doing the computations, making the displays is kind of up for people to choose. And that's where the packages that we plan to share with you today, that's where they come in. So in particular, cards and its companion package CardX, these are the engine for the analysis. So you see these coming in here to create ARDs. And then we have a couple of tabling packages that we're going to be sharing with you called GT Summary, T Format, that take these ARDs and render the displays, all based in R. And yeah, so hopefully you leave today with a good sense of what these packages can do. So what's an ARD? It sounded like a lot of people were really interested in ARDs, learned it. Maybe you're familiar with ARDs, maybe you just heard the term and you aren't really sure what it is, but it's a way to put your statistical analyses in a standard format. The ARD model is giving a standard and consistency for how you store your results. And in general, one of the main reasons to shift to an ARD-centric workflow is for reuse. You do your analysis once, you store it in a format that's very generalized, and then you can pick it up and reuse it for other purposes. The ARD doesn't contain any information about how results get arranged in a display and formatted in a display. It is really just the raw, unformatted values, again, fit for reuse. And, I already talked about reuse here, but you can imagine one analysis, if it's stored in a standard format, it can be picked up and used for a regulatory table, or maybe you subset it later on, use it for a shorter table in your presentation, or even a figure. So really there's endless possibilities for a single analysis. And because of this, it actually can change the way we think about QC, hopefully for the better. Traditionally, if you think about your own QC processes within your organization, there's a lot of attention on the final display. Okay, can we make sure that if you're doing double programming, oftentimes the QCer is trying to match the exact spacing, the parentheses, the rounding of the production programmer. With ARDs, we can shift the QC to the analysis and the values themselves, which is really what matters. And then everything else is aesthetics. So you can imagine that you QC once, and then it's, you're freed from QCing for every single display. On the other side, there's another consideration with this is that, you may if you're double programming, again, if someone else is creating an ARD in another language, let's say, there's going to be subtle differences in perhaps the precision of the values once you get to a certain point. So defining tolerance will be important. ARDs can be, just like any data frame, they can be saved out to a data set format of your choice, file format of your choice, or a JSON file even. Which a lot of the ARS is that sort of JSON or YAML format. So that kind of fits there. So ARDs, we have our cards package to produce ARDs, and that's what we'll be focusing on in the next part of this section. CARDS stands for CDISC Analysis Results Datasets, and yeah, we're pretty excited about all this package can do. It's part of the Pharmaverse, so you'll see it and some examples on the Pharmaverse site. Right now, it's a collaboration between Roche, GSK, Novartis, and it contains a variety of utilities for making ARDs that I'll be sharing shortly. It can be used as part of this metadata-driven ARS workflow, or if you just want to use it completely independently, separately, that's totally fine too. It works either way. And then we're seeing a lot of traction with this package, a lot of use, which is really, really great. All right, so I'm going to jump into some code now and show you what this actually looks like, this package. The cards package, the main functions start with ARD underscore. And typically it's ARD underscore and then whatever type of summary that you plan to make. We're going to start here with ARD continuous. Okay, so ARD continuous, the goal here is to make your continuous summaries. So with cards, you kind of know up front, these are my continuous variables, these are my categorical variables, and you pass them into the correct function. The first argument in all these functions is the data argument. So for the examples, I'm piping in the data. You can also do data equals. And then one of the arguments you will always use is the variables argument. So that's which variable in the data set you want to perform the operations on. Here, I'm doing continuous summaries of age in ADSL. ARD continuous contains a set of default summary statistics that you see here. You know, mean, standard deviation, min, max, and kind of everything in between. So I'll real quickly orient you to the structure of a cards object, which is really just a data frame, but it has a special class called cards. The variable column is the column, the thing we're doing operations on. Here it's just one variable, age. Context contains a little bit of metadata about which operations we're doing. So here we're doing continuous summaries. The context says continuous. Then we have a few columns that are specific to this calculated. We have a name and a label. So this gives sort of like a short name and then a proper label to the statistic at hand. Again, these are the default statistics that are included, but you can customize the label and all of that. The stat is the value this is the result. So the ARD, in the CDISC model, the ARD contains kind of some general rules. And so cards is our interpretation of the ARD model. That's a part of the ARS. Something that is core to the ARD in the ARS is that it's one record per computed value. So this is a very long data set, and that's why you see these all stacked up here. They're unrounded and unformatted as well, which is important for the reuse. That being said, cards contains the ability to store formatting functions should you choose to apply them downstream. In this case, the integers, you can do integers, and the default ones are integers. That kind of translates to how many decimal places it'll be rounded to, but you can do more custom formatting functions as well here. But these are just functions that are kind of stored for later, and I'll show that in a bit. All right, so this is our standard card structure. Moving into some of the arguments, a lot of times you want to compute summaries by a certain variable, like treatment arm. So you can pass that here, by variable, by arm. And we see a similar structure to before, except now we see a group 1 and a group 1 level. Okay, so this is a kind of a standard naming convention that, you know, if you add more levels of your grouping, additional by variables, let's say, this will just bump out and you'll have a group 2 and a group 3, and they're all kind of stacked up in there. So you can see the different treatment levels in the level. All right. And then statistics. So, you know, if you're happy with the continuous statistics that are built in, you don't need to touch it, but you can customize it as you choose. You can pass a custom function. So coefficient of variation, you can pass that if you had to define somewhere else, or you could pass something from another package, let's say. But you can do some custom stuff here. Yeah, any function, base R from a package, user defined. It's totally flexible. And then you can do, you know, I'm doing a silly thing where I'm duplicating age just for the purpose of showing you that if you have certain statistics you want to calculate for certain variables, you can do that. You can get really granular at a variable level for what you want to do, or you can just do, you know, the same summary statistics for everything. And then, of course, as the default stats, you can ask for just a subset. If you just want a mean and median, you can get those. So pretty flexible there. Real quick about the formatting functions. I mentioned you can store the formatting function. Well, it comes with the formatting function stored. If you want to go ahead and apply those, there's a helper function, apply format function, that you can apply at the end. And it creates, instead of a formatting function column, you have the formatted value. If that's something you want to just create and use, you can do that very easily. Here we were saying that we wanted to round everything or round all the means to 0 decimal places as a custom formatter. Another thing you can do is you can update the ARD with a formatting function later. So sorry, let me go back. The format function argument in these ARD summary functions, you can make sure that gets stored in advance before it gets applied. If you already have a cards object and you want to update the formatting functions afterwards, we have some update utilities that you can do. You can do that afterwards and then apply it later. So this comes in handy for some of the card X functions where the formatting it's not so flexible in the function itself. You want to modify it afterwards. You can do that. All right, so just want to show you ARD categorical as well. ARD categorical is the way to do tabulations. It just does n in percent and then the denominator. And so, but really, really similar syntax as far as the data, the by, the variables, all the same. You just see different statistics coming out. And because it's a categorical variable, continuous, we suddenly have a column called variable level, which represents the particular category of the categorical variable that's being computed on. So for continuous summaries, this isn't here. It's not needed because you're calculating the mean of age, let's say. But here for categorical, the level is important. All right. So very briefly, this kind of is information for later because we don't have a ton of time to cover all of this, but there's other summary functions as well. Dichotomous, hierarchical, complex, missing, they're all important in their own way. And some of them are intuitive, like dichotomous, you can imagine that's dichotomous summaries. Hierarchical, we're going to get into this in the next part of this section, but it's basically specific for your hierarchical summaries like AEs. Complex allows you to do more sophisticated summary functions, basically, if you need to do something that's not just univariate, if you need to incorporate more information from your data set through a summary function, you can do that through ARD complex. And you can find, we won't be covering that in the workshop, but you can find that information in the documentation of the package. ARD missing gives a variety of summaries for missingness. And because these all come out with a cards object in the end, they're all consistent and you can stack them up and combine them and everything. And I'll mention that there's a variety of helper functions to help combine things or manipulate the result or get extra information from the result. So again, I'll just point you to the website for more information here, and you might get a little exposure to some of these in the remainder of the workshop. But in general, definitely check out the documentation, the website for cards for more information there. All righty. So I showed you ARD continuous, ARD categorical by themselves. Sometimes you're doing a lot of different operations, let's say for a demographic summary. When you're computing demographic summaries, you've got a variety of continuous, categorical, dichotomous, different variable types that are combined into that analysis, right? So we have these stacking utilities in cards that allow you to do more things in one step, right? Things that have a consistent bivariable, a consistent data set, you can pass these through the stacking function. So there's a bunch of arguments to these as well, but I think the most important are data and by. And ARD stack allows you to pass as many of these ARD summary calls within it, and it'll kind of do them all together and stack them all up. Yeah, that's really helpful if you're doing a lot of different data types. All right, so let's go ahead to do an exercise now. If you want to open up the O1 cards part A, we'll be doing some demographic summaries, and I will go ahead and start this. Okay, well, hopefully, there wasn't too many questions coming through, so hopefully that was a good sign that people were able to work through. But I'm going to quickly cover the answers here. All right, so first thing was compute the summaries, the continuous summaries for a new set of variables: age, BMI, height, weight, by treatment. So we did the data argument for you, and here's the answer. So you put treatment in the by variable, and then everything else be as a vector. And it's really flexible too. If you wanted to pass quoted, put your age in quotes, BMI, quote, all that, you can do it that way too. So here's the results, and we see treatment and its levels in the group. Now this time, because you have multiple variables, you're seeing this stacked up, right? You see age, BMI. You can feel free to explore more of those interactively, but here's just a little printout, and those are all good. For categorical, it's very, very similar. This time we're putting age, sex, race, ethnicity in the variables. And again, you see those stacked up. You see what's different here, of course, is there's a variable level, and it'll just be specific to the different variables. Now ARD stack, which we love ARD stack for this kind of situation where we have multiple calls we're doing that share a common data and common by variable. That streamlines things a little bit, less code in general. You add those in here. So when you do your ARD underscore whatever, when you do those calls, you'll just omit the data and by from those, but everything else is available to you. If you have a statistic argument, anything else, you can put those in there. You just leave out the data and by, those are passed in from ARD stack. And then the result is all stacked up for you. Okay. And then I had a bonus. How do you do the overall summaries for all of the variables as well as total N? So overall summaries being do these computations without a by variable. So just the overall population. And then total N being like what's the total N denominator of this data set. Those are available through two arguments called overall and total N. And that's kind of just scratching the surface of ARD stack, but those are going to be things that you would probably use the most is what you're seeing on the screen. All right, so I'm going to move on now to the next part of cards. And because we're a little bit behind, I'll kind of skip the interactive exercise piece and just we'll walk through it together. And somebody asked, could you show the total N in the data? It appears at the bottom. So basically it's going to be the last row of the data set. If you want to pop it open in your viewer and scroll all the way down, you'll see the row for the total N. Yeah. All right. So hierarchical summary functions. These extend what's possible in ARD categorical. And just make it a little bit more custom for your hierarchical summary. So if you think about an AE summary and a preferred term, the preferred terms are specific to the system organ class they're nested in, right? So we want to make sure when we do, let's say, computations on or tabulations of the system or the preferred, when you do tabulations on the preferred terms, you want to make sure they're nested within the system organ class. So these hierarchical summary functions help you to do that and make sure that the denominators are right and the nesting is handled. We have two core functions for this. So basically I'm going to show you these and then I'm going to show you the stacking utility, which makes everything easier as well. But to understand the stacking utility, it's important to understand these first. ARD hierarchical is generally for calculating subject level information. So this is like any AE, right? As opposed to, or the percentage of subjects with any AE. That's a subject level thing. For any sort of event level information, like total number of AEs by treatment group, we're considering those event level counts or event level summaries that are handled by ARD hierarchical count. So depending on what you're after, you're gonna be using one or the other, whether it's that subject level rate information or just generally event level counts, those event level totals. So let's look at ARD hierarchical, the subject level one. The syntax is generally the same as a categorical, but there's some differences that are really important. Before, when we saw the variables argument, when you saw multiple variables, it was just kind of like compute on each variable. But this time, multiple variables has a specific meaning, and it's the nesting. So in ARD hierarchical, it's going to return summaries on the lowest level variable within anything else before it, right? So that nesting is important, and the summary is just on the last one. In this case, we're asking for tabulations of preferred terms nested within their respective system organ classes. By variable is the same. There's now an ID argument in here. That's the expectation is your data set will already have been kind of subset and pared down to the subject level information. This ID argument just does another little check that you don't have duplicate information. So it's asking for, what is the unique subject identifier for this particular calculation. Denominator is usually something that you want to use for these types of summaries where, in your ADAE, it contains only information about subjects that had AEs, right? but you want to make sure your denominators reflect the full population. And so the denominator argument is where you can pass the full population information. Okay. And that just impacts the denominator of the results. But under the hood, these are categorical computation. So it's using the ARD categorical under the hood, and it's just making sure this hierarchy is enforced, and it's checking for duplicates and everything. For the count, for the hierarchical, for the event level counts, there's less of a concern about uniqueness in the data at a subject level. And so you can ignore that part, and it's just going to do counts of the number of records for the particular AEs. And so you can do the nesting similarly. And what we see in the other side is just counts, right? These are just ends as opposed to percentages and things like that. So displays for hierarchical data typically report on every level of the hierarchy. We're not just looking at preferred terms, we're also looking at any AE by system organ class, or just overall, right? Any AE overall. So what this means is you're going to be subsetting your data to, if you're doing subject level rates, you have to subset your data at different times and do different calls to ARD hierarchical, which can be kind of cumbersome because these displays are very, very common. These types of analyses are pretty much always included in a clinical trial, right? So it can be a lot to do kind of every time. And so we wanted to provide a better way. And this I had alluded to is through the stacking functions. So we have two different stacking functions. We have the sort of subject level one and the event level one. So I recognize I'm going through this kind of quickly. So if you need to take time, we encourage you always to take time after the workshop and just kind of process these. But if you're doing a lot of the every which way AE tabulation, we do recommend you use the stacking function. It's just going to be easier. For the subject level stacking function, ARD hierarchical, or ARD stack hierarchical, when you pass a vector of variables, it's going to do this nested tabulation on every single one. It's going to take care of the multiple operations for you. So it'll do the preferred term nested within system organ class, and then it'll do system organ class by itself for these. Further, it will do the appropriate data reduction up front to reduce to the unique records per subject through the ID argument. So that's going to do the subsetting for each operation. So for instance, when it's doing the preferred terms tabulations, it's going to subset to one record per preferred term per system organ class per subject. And then for system organ class, it's going to do it there as well. We can, of course, pass our denominator as well. And to give you a little preview of what this looks like, you'll see stacked up operations in the end, of course. So we see our system organ class level tabulations here, and the preferred term tabulations within the system organ class just below it. And this is just a subset of the AE data set just for the gastrointestinal disorders system organ class. That's all I'm showing here. So you have all those results combined together. For the count, this is really, really similar, with the exception of it's just counts in the end, and there's no reducing down to unique subjects because you're counting all the events. So we don't have an ID argument for this one, but it'll do, preferred term, system organ, whatever level of the hierarchy you're passing in there, it's going to do it all for you and stack them up. And we see, again, just looking at gastrointestinal disorders, we see the total counts for those, 14 AEs total for placebo, as well as the counts for the particular preferred terms, which total 14 in the end. All right. So now I was going to do an exercise, but in the interest of time, I will just show you guys. Feel free to run it on your own as well, but we will a timer here. All right, so the exercise was just one question to calculate the number and percentage of unique subjects with at least one AE overall by system ordering class and by preferred term within source system ordering class. On top of this, we want to make sure these operations are also done within the treatment group and severity level. So we have a lot of by. How does this go? Well, the AEs are specific to these, right? So we want to make sure we're computing overall AEs and then system ordering class preferred term. These are the things we're computing summaries for. So they're going to go in the variables. The by variables are going to be treatment and severity. So let's look at what this looks like. The solution here. So we see our preferred term and system organ class. And by default, did I get that right? By default, it does overall. Or am I missing an argument, Daniel?
I think it might need the overall argument, but I'll double check.
Yeah, okay. So we'll check on that. But it's definitely going to do system organ class level and preferred term level operations with the at the subject ID level by treatment and severity. So I think in the prior examples, I didn't have that additional by variable. So that's a difference here, because you can have as many by variables as you need. Here we're breaking it down, not just by treatment group, but by severity as well, and making sure that the denominator is the full study population. So I know that's a lot. Okay, yes, thank you, Daniel. So what I'll do is we can update these slides after the workshop. And that's something I meant to say up front. These slides are like being updated live almost. So what's in your copy of the Posit Cloud workspace may not be updated after the workshop. So we just recommend you go to the website for any of the most recent slides. But basically, there's another argument called overall that should have been set to true here. That would give you this line, which is any AE, of course, by treatment group and severity. Great, yes. So this is the end of the card section. Again, I know that was a lot of content. I know we don't have too much time of a buffer, but if there's any burning questions, I'm happy to take them. Otherwise, we can keep doing Q&A in the chat and I can clear up anything while Daniel's getting into the next bit.
All right, so we are going to jump into the next section. Let me get my setup so I can see your comments potentially come through. I can't guarantee that I'll see them as I'm presenting. So if you are going to the workshop's website, we're going to be now going into section 2 on the Card X package. Let's head in. And I think everyone should be able to see what I'm saying, so that's great. So let's get started. So, as you saw previously, we've introduced the cards package and the analysis results standard from CDISC, and we're going to be moving into the Card X package and ARD extras. So Card X, you can read it as kind of extra cards. Cards exports these utilities for doing some pretty basic summaries, kind of your bread and butter counting and univariate summaries. And Card X is going to give you some extra ARDs functions for calculating some more complex methods. So, so right here, you can see that these two packages together are going to provide you a strong foundation for building ARDs in simple and both complex cases. which is why they're very similar. And just as an FYI, from a maintaining point of view, CardX is going to have a lot more dependencies on other packages that we're implementing those methods for. So it's much easier to maintain a simple, more directed package with very, very few dependencies like cards. So that's not going to change very much. But something like CardX is going to have more changes throughout its lifetime, which is why we kind of separated that maintenance into two packages. So that's why you're seeing two. So we already export ARD framework for a lot of statistical analyses, including methods from the stats package, which is kind of base-ish or base R adjacent, the CAR package, effect size, EM means, regression modeling packages, standardized mean differences, survey data, survival data. This list is growing rather quickly, even right now. So we have a lot going on here, but there's still a lot of room for growth here. And if your methods that you use at your company are not here, please file an issue. You can join the collaboration, and that would be wonderful. I love working with everyone in the community. It's one of the great joys, I think, in open source environment. So when I say more complex statistical methods, I'm going to start with the least complex statistical method, everyone's favorite, the t-test. So we have a function in CardX called ARD stats t-test. So in the CardX package, we use the ARD prefix for functions that are going to create ARDs, just like before you saw. But we follow another naming convention where we list the package name followed by the function that it's implementing an ARD for. So stats is the base adjacent package that contains the t-test, and t.test is the test. So that's why this function is called ARD stats t-test. So you can see here we're starting with a basic ADSL data set, and we are filtering so that we just have two treatment groups, because that's what a t-test can handle. And we are saying, can I get, please, a t-test by my treatment arm for variable age? So you could list more variables here, but for now we're just doing one. And you'll see below this very standard structure that you've seen previously, where we have our estimate, which is our mean difference. We have our means in both groups 1 and 2. And we have our t statistic, our p-value, our degrees of freedom, our confidence limits for the confidence limits for the difference. We also have here the Welch two-sample t-test is under the method section. And then you also see down here, so these are all of the results up on top. But one nice thing about these functions, which is really great for reuse, is that at the bottom, you're going to see a bunch of the arguments that were used in t.test function to create these results. So you can see down here, like on line 13, we have var equals false. So we know from looking at these stored results that we did not assume equal variances in this calculation. So imagine yourself in 18 months, 24 months down the road, reusing these results, and you're thinking to yourself, oh my goodness, well, did we use what exactly method did we use? And then it's all here. You know exactly how to recreate these results. So that's something that's really nice. One other interesting thing you might note here is that in the stat column, you have all these floating point numbers like negative 1.286 and 74.381, blah, 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 blah. But then on line 9, what do you have? You have Welch two-sample t-test. You don't get to see the whole thing, but that's what it says. This column is mixing numeric and character results. So just keep in mind when you're working with ARDs, we wanted to be able to both support simple and complex results. So that would be like scalar numbers or even scalar characters. So the stat column is actually a list column. So each one of these statistic results, they can be something as simple as a single number, but they can be something as complex as a variance covariance matrix, or even something far more complex than that. And it all works in a single column, and they can all be different classes. You can see this repeated on lines 12 and 13 when we have false, a Boolean or a logical here mixed with character and numeric results. So the framework that we have here is very flexible. So that's lovely that we've implemented a t-test method for you, but what do you do if your method is not implemented? The good news is that it's actually very simple to wrap the existing frameworks and to customize them for whatever you need. So you can see in this example, we're going to be wrapping ARD continuous, which Becca just showed us how to use for simple univariate results like means and standard deviations to do a one sample t-test. So here we're going to start out with our ADSL, just like we did previously, and filter on two treatment groups, just like we did previously to do our t-test. And just like before, we wanted to variables equals age because we're interested in age in this case. And here in the statistic, rather than sticking with our default, which kind of gives you the standard univariate summaries results, we're going to now specify a t-test by specifying a new function that's going to take our t-test, and it's going to pipe the result of a t-test into Broom Tidy, which is going to give you a one-line data frame. So the results in ARD continuous, they can be a single number, like in mean, but they could also be a one-line data frame or a named list, which is essentially the same thing as a one-line data frame. So the wonderful thing about this is you can utilize not only existing frameworks of ARD continuous, but the existing frameworks of the entire huge amount of work behind Broom Tidy to very easily take those tidied results and make an ARD structure out of them, thus being compliant with this emerging CDISC standard, which I think is a wonderful, wonderful option here. So, and then you can see here, the last thing I'm doing is piping it into a dplyr mutate to update the context. So by default, the context here was just like continuous for univariate statistics, but I wanted to be a bit more explicit for reuse purposes here, say this is a one sample t-test. And then you can see the results are printed down below. You may note that these results actually look a little different than the ones from the previous slide. Notably, it doesn't contain the arguments that were used in the one sample t-test. So maybe I could have done some other things like change the null value from mu equals 0 to mu equals 70, which would change greatly the p-value associated with this, of course. So when you do your own methods, it's important to make sure that you are documenting exactly what you're doing, because we won't have that in there for you. You can add them too as well, but just stacking those two data frames together. So here, if there's no questions on what you've seen thus far, I'm going to move into a bit of a more complex case where we want to do t-test still, but we want to do a two sample t-test. So that's not a strictly univariate operation, so we can't just use ARD continuous like we did previously. But we are going to start in the exact same way with our ADSL dataset and filtering on two treatment groups. But now we're going to jump into this statistic argument. I'm going to zoom out again, that was too much. So instead of just doing t-test, I'm going to make a function of x and do t-test and pass it to Broom Tidy. You can see that I'm actually using a different function, ARD complex. So ARD complex expects more than just a single vector input. It has a more complex input structure to its functions. Although it expects the exact same output, the input structure is a bit different. So in this example, I'm using, again, that simple vector input, which is going to be age in this case, because it's taking that from here on line 4, but it also has a data argument, which is going to be the subsetted data argument. So if I had a by or a stratified argument here, I could be doing this by treatment group, which is not what we want to do in this case, but I could be doing it, by some other characteristic like age group. And this data frame here would be that subsetted data frame. There's other arguments for the full data frame. So you can access all sorts of information from your results to build a slightly more complex function. So here, going to look at that function that we're creating here. So this looks very, very similar to the last function that we made, except for that we are also doing these things by arm. So that's really the only difference here. And then apart from that, now these results are looking much more similar to what we saw 2 slides ago, because we were looking at mean differences instead of a one sample t-test. But similar to the last slide, we don't have the input arguments to that t-test. But again, you can add them manually if you need to. I'll take just a quick moment here to also note that I'm adding this group 1 equals arm to add some additional context to these results, so that when you're looking at this ARD, you can say, oh, okay, well, this is a t-test, a 2-sample t-test of the variable age by arm, right? And then I'm using this utility function from the cards package to kind of put everything in a standard order, so that when you're just looking at it, it's all looking very, very similar to what you've seen before. Although not required, but it's nice. It's easier on the eyes. Card X also includes functionality to summarize pretty much every type of regression model in the R ecosystem. This is an abbreviated list of the known supported regression modeling functions. It includes things like MMRM, which is incredibly popular for repeated measures in the pharmaceutical industry, but really a whole slew of regression model functions. So this is fantastic if you're doing adjusted results or if your primary analyses require for covariate adjustment, for example. And let's just go through a quick example of like what does summarizing a regression model mean for card X. So to kind of illustrate what it can do, I'm just building a very, very simple Cox proportional hazards regression model here, where our outcome is going to be time to progression, and we're stratifying our predictor is arm, okay? And I'm using GT summary just to illustrate what the results look like to show you what's possible and what kind of information is stored in the background. So if you wanted to make this table, you can see here that the card X function, which is called ARD regression, is identifying each one of these terms. So the terms from the modeling object are just going to be the high dose and the low dose, but it's not going to be associated with a variable from your underlying data set, which it can actually identify and group all of these terms together. Which is actually really fantastic when you need to summarize regression models. You can see here that it was also able to identify our reference group. It was also being able to identify our results as hazard ratios rather than just your standard slope coefficient. And it gives us the standard stuff, those hazard ratios, their confidence intervals, their p-values. I think you would expect that in every case. But you can also get the total number of observations that went into the model and the total number of events that were observed. So in this case, you might think this is a pretty bad model because you have 6 events and 2 predictors, and I would agree with you. So this is not a fantastic model. But in addition to being able to do that for the entire model, it can do it for every one of your categorical predictors as well. The number of observations in each of these categories, along with the number of events observed in each one of those categories. It can do more than that, but that's pretty powerful. That's a lot, especially for the suite of regression modeling functions that it can do this for. That is super, super helpful information to have. This kind of just goes through that list again. And, it's contextually aware of odds ratios and incident rate ratios as well. And again, if you have complex contrasts as well, those are all handled and reported back to you in this nice ARD framework as well. But if you're interested to know more about this, pop into the chat and we can talk about it later. All right, so now I'd like us to go into our exercises and open up the third exercise for today. And we're going to be using card X to do some comparisons of some demographics. So these are going to be the same demographics that you computed previously with Becca, but this time we're going to be using cards to add a p-value to compare those values across the treatment groups. So please get started and jump into the chat if you have any questions. Thanks. And while you're getting started, I'll just share a small story. If you do like New York Times word puzzles, today's Strands puzzle has the word cards in it. So I thought that was a bit fortunate for today. If you have completed the Strands puzzle already, please don't tell me I haven't found the spanogram yet. It's a fun way to end the timer. All right, so let's go through this. So we wanted to compare the distributions of age, sex, and race by the treatment that subjects received. So we're going to first start with the Kruskal-Wallis test for age, which is our continuous variable. So like you've seen before, we are just going to pass our ADSL data set to a function ARD stats Kruskal test, which is again in the stats package Kruskal.test. And we want our results by treatment and for variable age. And you get a cute ARD out of this with our test statistic, our p-values, some degrees of freedom, and a character string listing what the test was. So that's very helpful. Continuing on with, I forgot who said it, but someone's favorite test, the chi-square test for sex and race by treatment. Um, Again, we're just going to go to our function in the CardX package, ARD stats chi-square, chi-square dot test or underscore test in this case. Pass your data frame, your by variable, the treatment, and the two variables, sex and race. And in this case, I filtered out some of the extra columns and rows just for printing purposes. There's nothing interesting happening there, just so you can see the results a bit better. But you can see here for sex, we have our chi-square test statistic, we have our p-value, degrees of freedom, and again, that text telling us what it was, along with those default argument values, which you can change, of course. And then we have the same repeated for race. All right, so the last part was going to be combining our results with cards bind ARD, which is very, very similar to dplyr's bind rows, except for it has a little bit more contextual knowledge of what you're actually doing. And if you accidentally were stacking two things that had repeated values, you're going to get some messaging about that. And so here we're binding these two ARDs that we saved, Krouse ARD and chi-square ARD, and I am filtering out everything except for the rows with the p-values. And you can see here we get a cute little baby sized ARD with just 3 rows, 1 row for each of the variables, and the p-values for each. Now, one thing I wanted to point out here that I really love about this package is that it's going to capture the errors and the warnings for you. So you can see here that for race, there were some races that had low frequencies of observations, and therefore you actually are getting a warning returned from the chi-square tests in R. And rather than feeding those warnings to you and then them being lost forever, it's capturing them for you and putting them in this warning column. The same thing would happen if there was an error as well. I think I have an example of this coming up, but just wanted to show you a case of that in real life. I think it's a very nice feature. Okay. Oh, yeah. So here it is. So what happens when things go wrong with ARDs? So in this example, I am using one of our bread and butter functions, ARD continuous, to calculate the kurtosis, which is kind of like the variance of the variance in a way. And I'm going to be doing this by treatment arm and for variable age group. So just up front, I'm doing something you shouldn't do. I'm trying to calculate a continuous variable summary on age group, which is categorical, and in this case, a character. So I'm saying here, can we get the kurtosis for a character variable or vector, which is just not possible. So you can see here that in this case, you still get your ARD back. You still get it with each of the grouping levels. You still get the stat name. You don't get any results because there are no results. But what you end up seeing here is that you are now getting warnings and errors populated in those columns. And because those have been populated, they do appear in the default print method, where usually they're kind of just like, oh, there's these other empty columns, errors, and warnings. But because there is something significant to report here, you are seeing it up front. And if you were to print these results, you would see that we saw the following error while calculating kurtosis for age group 1, non-numeric argument to binary operator. So that's the error that we've captured for you so that you can you can use that as you need contextually, right? So the nice thing about this is that imagine you're so early on in your study, but you really wanted to get a head start on calculating all of your ARDs and then maybe your tables next. And from there, you wanted to go on, but you don't have enough data to actually calculate the statistics needed. You get the ARD structure in its standard format returned back to you, and you can populate that stat column with just a bunch of NAs if you'd like, or anything else you'd like, and you can move on with your life and still build those tables. Again, noting and being able to report that it's not actually calculable at the moment. We also have functions for creating mock tables. So like mock tables, mock ARDs are often quite useful. So in the cards package, we have these functions with the mock prefix, like mock categorical, mock continuous. You kind of just tell it what it is. So in this case, the mock categorical is saying that we want to do a variable age group, and it is character with these 2 levels. And then we do something similar for continuous age. And you can see we get this mock ARD out of everything, and you can see the statistics are empty because there's no statistics to report. But I did run this function, apply the formatting function, and by default, the formatting function for these mock functions is just going to return some x's. So for something like an integer like n, you're going to get two x's, and you can change how these x's look. That's very easy to do. And for something like a percentage, you'll get xx dot x. And what's really cute about that is then you can take this ARD and you can very, very easily take that result. So here's that ARD we just calculated, and you can pass it to any of the table making packages we may be talking about in the future, the next hour, and build table shells. So you can, from the very beginning, without any data, start building all of the tables that you need, which is a wonderful thing to be able to do. There are other representations of ARDs that are possible. So here are two examples, YAML and JSON. So you can take your ARD, the one that we just calculated previously, or a couple slides back actually, and you can represent them in different ways. So these are language agnostic ways, whereas the data frame is of course very R-centric. These can be useful for a variety of reasons, for moving across various languages. It's easy to create a REST API from a YAML or a JSON object, so that you can easily like hit it with API calls to get the statistics that you want for other reporting things that aren't just your tables and figures, for example. All right, so what we're going to do now is we're going to take a 10-minute break, and we will be back after the break with more on using ARDs to build outputs. And if you have questions, please pop it in the chat during the break. Thanks. Talk to you soon. All right, that is our break, everyone. Hope you enjoyed it. And I hope you've enjoyed the first half of the workshop as well. We're going to be moving on from constructing analysis results data sets and using cards and CardX into what you can do with them in building tables. So first up is GT summary. And if you do have any questions about the ARDs, then that was a perfect time to get them in before we get started on the next part. So without further ado, here we go. So like we said before, we've done cards, we've done CardX, we've done some extras, and now we're going to be using those ARDs to build some tables. So, like everything else we've done before, please continue to ask questions in the chat as they come up, as they're in the slides, and we can address them immediately. So the first release of the GT summary package was kind of a long time ago, back in May of 2019. And it began when I was working in academia, and I wanted my team of statisticians. I was working as a statistician for 13 years at Sloan Kettering Cancer Center, and I wanted my team to be doing their work at a highly reproducible level. And I wanted them to switch from a proprietary language that shall not be named to R, because R Markdown was just a fantastic tool for reproducibility. None of us knew R, and so we thought, we'll just switch to R. And I was like, oh, I'll just build a little package to help with some of our common reporting. The package has grown a lot since then, and it's become quite popular in the ecosystem. But really our goal was we wanted something that would do reporting that was both very, very, very simple to do, but also keep it very customizable. So that's how it started 5 years ago, and how it's going is that now we have over 1 million installations from CRAN, 1,000 GitHub stars, 300 contributors, and 50 code contributors. The package has won the American Statistical Association's Innovation in Programming Award a couple of years back. And most recently, someone created an entire CSR, not someone, Augustin, he created an entire CSR using GT summary, and that won the 2024 Posit Pharma Table Contest, which was great. So it's really gained a lot of momentum over these years and has a lot of users, which is super helpful for joining into the pharmaceutical world for a lot of reasons. One of the biggest benefits of having lots and lots and lots and lots of users for a package is that when you find those edge cases and those weird bugs, probably someone else found it way before you got around to finding it. So that's a really nice thing about having a package that's widely used. So GT summary does a lot of type of reporting, demographic or table one types if you're doing publications in journals, which is where we were primarily using it originally. Cross tabulation, regression model summaries like you saw before, survival data summaries, survey data like complex survey weights, and a lot of custom tables as well. And we're going to kind of focus on the ones that are most common in the pharmaceutical industry, which are going to be your demographic type reporting tables. And so it also has functions for inline reporting and stacking and merging things together and theming tables so that just with one call you can change the defaults of a lot of these functions to look at just like what your company likes to see. And although the package is called GT summary because we default to printing with the GT package, there are many print engines supported, including GT, of course, Cable Extra, Flex Table, Hux Table, Cable. You can print them to Tibbles. So it's very flexible for the various output formats that you may or may not need. So this past summer, so of course ARDs wasn't a thing 5 years ago when the package was originally written, but this past summer, it was refactored to run on ARDs. So that means that if you take your data frame and you pass it to the most basic function in the package, which is TBL summary for making a simple table, summary table, that every calculation is done by cards and CardX in the background. So that means that when you generate your beautiful little table that you can see here, you can extract the ARD out of that table. If you have more complex situations where the statistics you're presenting are more complex, you can, of course, build your ARD first and then pass that to the sister function to TBL summary, which is TBL ARD summary. And again, very, very simply build that table. Now, I said before, we wanted to have like a very simple user experience for this, which is why I think the package has become quite popular, is because it is very, very simple to use. And the ARD first framework also has a very simple API and has a nice user experience. So I think this is a big win for the industry. So in our workshop, we're going to focus on like 4 primary functions that are kind of like basics of reporting: TBL summary, TBL cross for cross tabulations, TBL continuous for doing continuous summaries within like a matrix or with subgroups, and something called wide summary, which you'll see. Just briefly, we're going to be using an example data set called trial, which is just like a 1 line per patient data set. Patients either receive drug A or drug B, and we have outcomes like whether or not their tumor responded to treatment, whether they passed away, and some baseline characteristics like age and T stage and grade of their tumors. Each one of these columns is labeled, so that will work as well. Those labels will be used by the package as well. But for primarily in this presentation, we're going to use a subset of this data set called SM trial, which we're creating right here, small trial, which just has treatment, age, grade, and response. So the basic function, TBL summary, which I mentioned previously. Let's get started. Like I said, we really wanted something very, very simple. So you can see here that I'm starting with a data set, the trial data set. I'm removing the treatment variable because we're going to use that in a moment. And I'm just passing that to TBL summary with no arguments. And what this function is going to do, it's going to take a look at each one of the columns that you have in your data frame, and it's going to decide the best way to summarize that. And you can see here that with this very, very simple syntax, you get a demographics table that's pretty much ready to go. In many fields, this is ready to go. So there are going to be 4 primary types of summaries that you're going to see here. One is continuous, which you're seeing for age. So when age is summarized on a single row like this, that's a continuous summary. Continuous 2 is going to be more similar to what you see in demographics tables in the pharmaceutical industry, which is going to be 2 or more rows. So it'd be like maybe a row for mean and standard deviation, then a row for median IQR, then maybe the min and max. And then following that, we have categorical data like you see for grade. And then we have dichotomous results as well, which are categorical variables that are represented by a single value here. So tumor response is coded as 0, 1, and you are seeing 1 here, how many people actually responded to their tumor. And this is all very modifiable to meet your needs here. But these are the basic defaults, which I think are really wonderful for many cases, for many, many cases. But let's customize our output just a bit more. So let's pass that same data frame to our TBL summary function. And this time, let's pass the argument by equals TRT. So that's going to do the exact same table, except for this time, let's see our results by the treatments that the subjects received, drug A and drug B. So you can see here that now we have in the header drug A and drug B along with their counts. But let's further customize it to be exactly what we like to see. Like I said, in the pharmaceutical industry, we do things, continuous variables on 2 or more rows more often. So here I'm saying, instead of using our default continuous type for age, let's use continuous 2. And you can see that now age has a header row and the median IQR is now on the next row. Continuing with that, let's change the statistics that we're reporting to something that would be more common in what we see in our CSRs. So that's going to be for age, the mean and the standard deviation, and the min and the max. Okay, so this is using glue syntax, these curly brackets that you're seeing here. And this glue syntax is usually used by the glue package to just insert a single value into whatever it sees inside those curly brackets. But in this case, it's doing double duty. It's looking inside those curly brackets and it's saying, I should put the mean here. It's looking for a function called mean, and then it's going to go take your age vector, calculate the mean, format the result, and then put it back into the string in this exact format. So you can see here that because we put here mean in curly brackets, and then standard deviation is also in curly brackets, but then also surrounded by just regular parentheses. And that's what we see in our table as well, the mean and standard deviation. And then again, for min and max, we wanted them separated by a comma. So you just say min, max with a comma between them, and that's exactly what you get in the table. So, and then response, well, typically you just see the N and the P, but you can also include the big N if that's what you'd like to see as well. So that's what you can see here. 28 divided by 95 is 29%. So that's what you're seeing down in the tumor response. So these are probably the most common modifications to the default output that you do see in GT summary for the pharmaceutical industry. But let's continue. Let's instead of just going with our tumor grade, or I think the default label was just grade with a capital G. Let's change it. Let's customize a little bit. And let's say this is pathologic tumor graded. So a little bit more directed, a little bit more detail in what we're actually reporting in this table. And you can, of course, change the number of digits that everything is being rounded to. So in this case, I'm using 1 as an alias, which is also recognized in cards and card X as, can you round this to 1 decimal place? But you could also put really complex formatting functions in here as well. If you had something that was like for significant digits, like I wanted everything in this table reported to 3 significant digits, regardless of, what that looks like. So that's also possible, which is also possible in cards as well. So just throughout the GT summary package, you're going to see some syntax that looks like this. And this is syntax that's also used in the GT package, in the cards package, and the CardX package. And you're going to see some formulas that are kind of on the left-hand side of a formula and with some kind of instruction that appears on the right-hand side of the formula. So when you use that formula syntax, you're actually invoking tidy select. So and this is again a true in cards as well. So when you see syntax that's like C with age and marker unquoted, we are going to go past that through tidy select to select the columns age and marker from your data set. You can also see here that we're using a function starts with, which is from tidy select. So of course you can use something like that to select age. This is the only variable that starts with AGE in this data set. But then we also have GT summary selectors as well that are specific for this package, like all continuous, which you see here, but we also have all categorical, all dichotomous, some others that are running around that are helping more complex cases, because oftentimes you want to say things like, you don't want to say, do this for age, do this for BMI, do this for this marker. You want to say, can you just do this for all of the continuous variables? Give me the mean, the standard deviation, the IQR, the median, the min, and the max for all of the continuous variables. And that's a really nice way to do that as well. And of course, when you have more than one set of instructions to pass, you can just drop it into a list. But when we're working with like small sets, I do just prefer the named lists where I can just say like list age equals patient age. That's great for labeling. So like I said, there were a bunch of selecting helpers that are specific to GT summary, like all continuous, all categorical. There's one called all stat calls, and we'll show a couple of examples of that in a little bit. which is great for selecting like those columns that have statistics reported in them. Um, but the lovely thing about GT Summary is that you don't have to know what your whole table is going to look like when you get started. I mean, it's obviously helpful to know what you're going for in the beginning, but you don't have to construct the whole thing from the very beginning. You can really start with an easy bit and just start adding pieces on to make that final, more complex table. So we have a whole suite of functions that begin with the prefix add, which are going to like add additional columns or statistics to your table. There's a whole suite of modify functions, which are going to be like decorating your function, like your table. Like I want to add footnotes or titles or bolding, italicizing, and alignment, these kinds of things. And then these lastly, we have some that start with bold and italicized, which actually are just wrappers for modify to do some common bolding and italicizing you may need to do. And we'll show some examples of how you can construct these tables one step at a time. So you saw in the previous slides that you can, again, just construct a simple summary table by treatment, which we have here, and then just pipe that into add p, which is going to add some p-values comparing those distributions, right? And of course, we have defaults that are quite sensible. You can see in the footnote here for the continuous variables, we have the Wilcoxon rank sum test, and we have the Pearson chi-square test as the default for grade and tumor response. But these, of course, these are very, very customizable, including to very complex methods with like adjusted p-values or repeated measures. And it's really easy to do those. And a lot of those are already built into CardX for you. And if they're not built into CardX, it's actually, again, very easy to write custom functions yourself. So this is just one way to just build on that base table, summary table that we're showing here. Another common way to build on a table is you say, I want some overall statistics. So I've done primarily things by drug A, drug B, but I also want to see what things look like for all of my subjects combined. So add overall is an easy way to get that done. It's also common that you'll want to see a column with the number of non-missing observations. So add n can do that. And this is, of course, customizable to give you just, well, first the default is the number of non-missing, but you can add the denominator, you can add the percent of missing, non-missing, you can report the number of non-missing, or you can report the number of missing. You know, really easy to change those defaults here. There's an add stat label that is going to move that footnote that tells you that I'm doing like the median, the IQR, or the number of n and percent from that footnote up into the label or the label row for each of those variables. So it's very, very clear exactly what you're presenting in all of these tables. And the reasons why these helper functions exist is because, you know, various publications like JAMA requires you to have median IQR next to age, like JAMA, the journal, whereas some journals don't. So we want to just be able to make it easy to fit your reporting needs. And you'll also see that if you look at the FDA specs for a CSR, that they also put the n and the percent up here in the labels for the variables as well. So that's why this is here as well. You can bold and italicize things. So in the FDA specs, they actually always bold like things like age, grade, and tumor response. Although I think in a lot of companies, I don't see that same thing happening, but the function is there to make it very easy to do. And if for whatever reason, I don't love this personally, but a bunch of journals required it, so we did add it, but bolding significant p-values. So this example didn't have any significant p-values, so I moved that threshold up from like the standard of 0.05 all the way up to 0.8, which is a pretty big p-value, so that I could get a couple of bold p-values for you here in the presentation. But really just wanted to give you an idea. Again, you can just compose these tables a step at a time. But I also want to show that they're very, very modifiable. So here we're starting again with that basic table. And instead of say having drug A and drug B, maybe I want to obfuscate that a bit and say just group A and group B. So you can, of course, there's a modify header function and you can change stat1 and stat2, which are the names of those columns, by the way, which there's a function that will print all of the underlying column names for you. Just change that to group A, group B. You can add spanning headers. Saying I want this across all of my stat columns. So all stat calls is that selector to say all of those statistics columns, I want this to go over it. So this is the drug assignment for group A, group B. And you can, of course, add footnotes, change the existing footnotes, what have you. So just a couple examples walking you through those kind of basic things that you're going to be doing pretty often. This is one of my favorite functions when I was doing a lot of applied work in academia because it's so common that you just want to compare the results of different treatments. And I could make the simplest summary table. In this case, I'm comparing a post-baseline marker measurement and tumor response. And I want to see, well, what's the difference between these two groups? And you could easily just pass the add difference function, which is going to add three columns, the difference, the confidence interval for that difference, and the p-value. And just like for add p, add difference supports a lot of methods that include simple things like this two sample t-test, but also a lot of complex things like MMRM for repeated measures data and adjusted p-values and adjusted differences and standardized mean differences as well. So it's like there's a lot that can happen, but this is just our basic defaults for you. And when the existing functions don't meet your needs, there's an add stat function that's very general to make it simple to add any kind of standard statistic, any kind of bespoke or tailored situation you're in. Okay, so this is all about ARDs, but where are the ARDs? So I did mention that ARDs are the backbone for all calculations in GT summary, and every GT summary table saves every ARD in the back end, and they can be extracted individually or combined. So here's an example up here where we are building our TBL, our table, which is our basic TBL summary, and we're building our summary part and then adding a p-value as well. And then there's a function called gather ARD. So you just pass the TBL object to gather ARD. And in here, I want to go grab my ARD from the add P results. And from here, I want actually just the results for age. So these are simple ways to just kind of go through that. You can see here that this is actually the Wilcoxon signed rank test. There are the results over there. Just had to scroll over a bit. And all of the results are here for us, just waiting to be used and reused. And one really nice thing about this setup too is that no matter how you construct your table via data frame first, or via something like an ARD first framework, these ARDs are sitting here ready for you to QC the results, which is really nice. It's a very standard structure, which makes it super easy to QC results, which is something that Becca touched on during the cards presentation as well of the workshop. So there's actually a lot more going on here. And like I said, there are so many users of this package with so many diverse needs. And only in the last maybe 12 months have my focus shifted to the pharmaceutical industry because I have been in academia previous to that. So as we find more needs that we can add or more functions that we can add to make our lives in pharmaceutical industry much more easy for reporting, we can continue to add those. But I think even as it exists now, like I said, it won the the Posit Pharma table contest by Augustine creating the entire CSR using GT summary. So it's very capable as it is now, but that doesn't mean we can't make it a little bit simpler in some cases as well. So let's start our first exercise using GT summary. We're going to create a demographics table. So if you can get started and go to your Posit Cloud or locally if that's what you're doing, and go to the O3 GT summary part A script and complete the exercise. And as always, jump into the chat when you have questions. All right, that's our time on the exercise. So let's just do a quick walkthrough. So here we wanted to create a demographics table split by treatment, including age, sex, and race. So let's just step through the bits. So TBL summary is going to be your main function here. And so we're going to start there. And we want our results split by TRTO1A. We're going to include variables age, sex, and race. And we want age, which is our continuous variable, to be continuous 2 for 2 or more rows on the summary. And due to that, we need to change the statistics. So we want to report for age to the mean, the standard deviation, and the median, the IQR. And that's how you get around that. And we also wanted an overall table. So we just pipe that right over to add overall to get an overall column in our table. And print it, and you get this gorgeous table. Wow. It brings a tear to your eye, right? Is it too easy? Maybe, but that's a good thing. All right. Again, if you have any questions on this, on how one could modify it, just pop into the chat. And again, here we're going to extract that ARD from the table we just made using gather ARD again. And here I'm just gathering that ARD and selecting that TBL summary component. Otherwise, it's like a named list from each of the functions you call. And so there'd be another section for add overall, for example. And you can see that, again, we did our grouping was by treatment. Here's the placebo results for sex and the high and the low dose for our active drug treatments. And again, that goes really, really long for all of the results that you see in the table. Just to give you an introduction, a quick peek at some of the other structures of tables that are really common and easy to report with GT Summary. Here's a cross tab that includes margins on the row, but also column margins are very easy to add as well. This is a TBL continuous, which gives you continuous summaries by treatment and grade in this case. So in the middle here, we have median and IQR for age. And here we have a wide summary where you have statistics that are reported in separate columns, which is pretty common as well. And of course, you can change the statistics that you're reporting here very, very easily. But in this example, we're doing the median in one column and the IQR in a separate column. All right, so that's kind of what we're going to move into some other examples here. And now we can see there's also, just like how we have ARD hierarchical, we have TBL hierarchical, which has nearly the same API, the same user experience, what have you. And you can get your beautiful, 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 very beautiful tables for adverse event reporting, which if you're doing these by hand, they can be quite cumbersome and tricky. And here we're using the denominator argument, just like we did in the ARD example, to say, I want my denominators to be coming from the ADSL dataset. And here we're renaming the ADSL variable arm to match TRTA, which is how the variable is called in ADAE. Why they're named differently? You'll have to ask someone who's better at statistical programming than me, but it feels like they should have just been named the same all along. Anyway, that's that table. So like these types of tables, and there are arguments to do these tables also including AE severity, grade, what have you. And so all of that it can be really simple and makes your life much easier. One reason I think that the GT summary package became quite popular is because while we've shown you a bunch of single, simple tables, the results of each one of these tables is quite modular, and you can build much more complex tables very easily from those basic components using functions merging and stacking, the TBL stack, TBL merge. So for example, what if we needed our tables side by side? So here's an example where we wanted a column of n, but we also wanted results that come out from TBL continuous, which you just saw in the last a couple slides ago. So on the left, you see here's a very simple table that just has n in it, and then another simple table that has the median IQR for age in treatment and grade groups. And so if you wanted to put those two things into one single table, it's a very, very simple call to TBL merge. Just put both of those tables in a list and pass it on to TBL merge, and bam, you get one single table that has all of the results in it. So that is as easy as it gets. We have very similar functionality for stacking. So in this case, I did two separate tables for drug A and then one for drug B, doing a quick summary of tumor response and proportion of patients who subsequently died. And then I'm getting plopping those into a list and passing it to TBL stack. And you can see here that now I have one section of my table for drug A and then another section of my table for drug B. And there are various ways to include that header or not include that header, of course, options for customizing. There's another function called TBL strata that does similar things, but first will stratify your input data set by whatever the stratifications are. In this case, we're doing it by drug, and then pass each of those subsetted data sets or those stratified data sets to whatever functions you're going to do. And at the end, it's going to either merge them or stack them, depending. The default is to merge. So here, I'm stratifying this table by drug, and I'm doing each one of these little component tables, and they're getting merged together. So that's just an example of how you can construct more complex tables very, very easily with using these tools. And then here is essentially the same thing, but stacking instead of merging. We are running a little low on time, so I'm going fast, but if you have questions, please ask. a number of years ago at this point, there was a group of epidemiologists out of Karolinska Institute, I believe, and they said, "Hey, we love the package, but there's this basic table we make all the time in epidemiology that looks like this. Can you make a table to do Cochrane-Mantel-Hansel tests for us in odds ratios?" And my first reaction was, "Yeah, that seems very reasonable." But then thinking about it, I had been maintaining the package for a couple of years at this point, and I thought, wait a minute, if I put this function in, then I have to maintain it for the rest of my life, which is hopefully a very long time, right? So rather than putting the function in GT summary, I showed them how they can easily construct this table by building the components, and then I wrote the function for them and said, now you take this function, put it in your package for your group, and you maintain it for the rest of your life. And that has been a lovely model to live by. So here's a fairly complex looking table, but you can actually break it into some pretty simple components. In orange here, we just see that in the control group, that's just a cross tabulation, just showing the counts. And the crude is that overall, that row margin that we just put on the top instead of on the bottom where it is by default. Then you can do that for cases and controls separately and just merge those together with TBL merge. You can TBL stack to get stage and grade all together as well. And you can get those odds ratios by just doing add stat, which is again our function for making custom statistics into your tables very, very easily. So this seemingly complex operation is just actually 4 simple operations put together, and now they can get the table that they need. And like I remember this table; it is very common in epidemiology, but I just didn't want to have to maintain this exact format forever. So, like I've said, cobbling the tables together with merging and stacking and stratifying is incredibly useful and incredibly powerful. But there's one other thing I just wanted to note, that the internals of a GT summary table are super, super simple. So essentially what it looks like on the inside is 2 primary objects in a list. One is a data frame, and the second is instructions for printing that data frame and making it cute. So here I'm actually extracting that data frame that we're printing, and you can see here that this underlying data frame is exactly what you've seen before. We have age, we have our median IQRs here, split by stat 1, stat 2, which is drug A, drug B, and then we have the same for grade. So if you actually need to make if there's no function that's going to be easy to do the modification you need, you can just go straight into this data frame and change it as needed. Also, if there's just some wild bananas table that you need to make, you can construct that wild table as a data frame and then just convert that data frame into a GT summary object as well to take advantage of some of the other features we're going to talk about in the future in the next couple of slides. So I think the simplicity of the API for the users coupled with the simplicity of the internals and the internal storage of this data frame make it super, super easy to get exactly what you need out of these tables. So we've been talking about data frames first, but there's also constructions for ARD first tables. And so each one of these functions, TBL summary, TBL continuous, wide summary, what have you, they have like an ARD analogous function or a sister cousin function. Not at the same time, sister and or cousin function. So, in case you're doing something more complex than just means and standard deviations, then you can do really complex statistical analyses. And instead of those means and standard deviations, the ARD has the exact same structure, whether or not you're reporting means and standard deviations, or you're doing something very complex like least squares means or adjusted differences or p-values from complex models. So all of that still fits in with this construct because these ways to organize the results are very, very general and kind of meet your needs for cobbling together tables. So we'll just go through an example real quick here. This is what you saw previously using cards package and the ARD stack function to get some continuous summaries for the variable age and some categorical summaries for the variable grade. And in this case, we're going to add the argument attributes equals true. So Becca did say like, oh, there's some other arguments that you can or cannot, you may or may need. So when working in GT summary, it's nice to use attributes equals true because it's going to go into your input data set and it's going to look to see if you have any like column labels assigned. And if you do have those column labels assigned, it's going to use those in the constructions of subsequent tables, which is really nice. So here's what you've seen this before. It's just the exact same thing. So we're going to move quickly past this one. And then you can just pass that ARD that you just constructed into the function TBL ARD summary, and you pretty much get exactly what you would have gotten if you would pass a data frame with 2 columns, age and grade. I'm looking at the time, and I'm so sorry, Becca. I'll speed up. We're going to go through this part pretty quickly. I just noticed. So this is something more complicated. Where you're going to do things by treatment. You're going to want those attributes. We're going to also do overall. So you have A and B stratified, but you also want everything overall. And then here we're going to pass those results to TBL ARD summary using arguments just like what you saw previously to get the results that you want and the table that you want. And we're going to add a caption in this case. So there's your table. I need to go quickly here. So like I said, if you're going to be building like something simple like demographics, use your data frame first methods, which are going to give you the table and the ARDs. That's the easiest way. But when you are doing something more complex, like in this case, we're doing a 1 sample t-test on age, but we wanted them in this format because we're doing subgroup analyses by treatment and grade, then you can use that ARD, which has a similar structure regardless of what statistics are in it, complex or simple, and you can still get your really beautiful tables out very, very simply. So rather than going through it, we're going to skip this exercise, but it's essentially building a demographics table using an ARD first framework, so which is what we just went through. So I'm just going to skip through it. But the solutions are on the website, and look at that, beautiful. I love it. You love it. We all love it. All right. You can create table shells very, very simply using this framework. So just build your ARD, tell it the formatting function should just return X's all the time instead of actual numbers, and you can pass it to TBL summary and you get lovely table shells. So again, you can build all of your shells before you even start, and the exact code that you made your shells with is the exact code you're going to use once you actually have data. 2 birds, 1 stone situation, maybe even 3 birds in some cases. I want to talk about themes. Themes are a really nice way to customize a whole slew of arguments and defaults all at the same time to meet your needs, your company needs, an example. So this is kind of your default output here using the standard defaults. But if you're reporting to JAMA, if you're going to be publishing in JAMA, you just run this top level function, the journal theme, and specify JAMA, and you're going to get some differences by running the exact same code. You can see your median IQR labels up here, your IQR separated by an M dash instead of a comma. And there's a couple of other small little differences if you go look at some other tables as well. There are language themes as well. So translate all your results into whatever language of your native tongue. That's lovely. There are like maybe 16 languages supported here. There's a compact theme because GT by default kind of prints things like with a lot of padding, which is fine for one table, but we're oftentimes dealing with a lot of tables. So reduce that default font size and padding with a compact theme. I don't have a pharma theme in GT summary right now, but it's very easy to write one, and you'll see one in the next slide where you can have like a monospaced font if that's what you want, different formatting for for percentages, what have you. So anyway, lots more on themes. You can build one specifically for your case, and it's really nice. So in this example, you can also use themes to construct new functions. So I wrote a function called TBL demographics that is going to wrap TBL summary, but just with different defaults, and those different defaults are set via themes. And so you can see here that we're getting our N, our mean standard deviation, our median IQR, and min and max, all by default, just by the number of lines to write this TBL demographics wrapping TBL summary is super minimal. I think it was maybe 20 lines total. Which is like nothing for a really complex function like this. Oh, and also I wrote a little Roche theme to give us our monospace output as well. GT summary tables can be printed to GT, which is the default, but also flex table, hux table, cable extra cable tables. Flex table is like super great for Word output. GT is fantastic for HTML. Also, Word is nearly there, but I'm looking forward to being perfect for Word as well very soon. Once you convert your TBL summary object to GT, for example, with as GT, then you have access to hundreds of functions to decorate that table with GT functions in any way you want. Really, it makes it possible to get any function, any table that you really want decorated in very bespoke and tailored ways. So in closing, check out the website. There's lots of documentation there, lots lots of examples. Thanks to all of the package contributors and authors. There's been many of them over the years. Yeah, check out, and also when you have questions, go to Stack Overflow. There are already thousands of questions that have been asked and answered there. So it's a fantastic place. And right now we're kind of toying with the ideas of feeding all of those posts on Stack Overflow that are tagged as GT summary into our LLMs to kind of train it a little bit more specifically on these tables to build our CSRs really, really easily, or build new bespoke tables just like that. So looking forward to how this goes into the future. And Becca, can we hear a bit more about T format as well?
Yes, yes, yes. All right, so you'll have to, okay, good. And something I wanted to throw in here awkwardly in the middle is that everything I've said up till now and will be saying reflect my own views and not that of GSK. Better late than never.
Me too.
Me too. Okay. Yeah, all right. So I will try to give you like the whistle stop tour of T format now. And I've done something weird with my window. Sorry, just a sec. There we go. Okay. So T format, we're talking about another package to create tables. So, you know, we try to do a little bit of framing for you all, because I know like sometimes you're trying to navigate the space of tables and the tools that are available. So we try to give you a little bit of framing of what each one might be used for, at least at a super high level. I think getting into the details and trying to decide like what might be good for your use case, it'll be up to you to do that research. But I'll draw some very clear distinctions up front. There we go. Okay, so here we are, last section. T format, unlike GT summary, Daniel showed all these many utilities of GT summary. GT summary can take ARD as input and create a formatted table, or GT summary can do the analysis as well. T format is strictly for taking an analysis that already exists, or an ARD, and formatting it as a table. So T format just does the formatting. So that's really important to notice, to note it's not an analysis engine. Something else important is that it's metadata driven. So you are essentially, with T format, you're defining how you want your table to look in the form of metadata. So all of those formatting instructions are defined independently of the data. And what that means is we can reuse it from display to display, or throughout the study, which I'll show you in a minute. So yeah, it's the metadata allows for a lot of power and reuse. And then yes, keep in mind that it's an ARD first tabling engine. And just like GT summary, it uses GT as the engine. T format, it has one main function for creating the T format object itself, which holds all this metadata about how a table should appear, and allows you to, as I said, define those separately from the data itself, from the analysis itself. So, this font is kind of tiny, but I just wanted to illustrate all the different options you have for arranging and formatting different elements of the table. All right, so let's do a quick tour of the many uses of T format and this whole concept of reuse. How does that come into play? So what you can do, because you can define this formatting without data, you can define it at the very early stages of your study before you have any data available, when you'd be creating those displays. So we've seen some functionality in cards to create mocks. We've seen some functionality in GT summary. Mocks are also possible in T format. And it's separately from the data. So there's this function called print mock GT that you can use to make your mock. And what it requires at minimum is a T format object. And I'll get into what that looks like in a minute. And then you can optionally provide a sample ARD without any values. And it creates a table that looks like this. If you didn't provide that sample data, T format will look at all the formatting that's defined and try to generate the mock display without a sample data set. So notice this object's name, T-format. You can reuse that same exact formatting object later on when you have an ARD available. And instead of print mock GT, use print to GT, and you get a table with values. So we go from the mock to a table with values without redefining the formatting. We're completely just reusing that object. And then later on, another element of reuse that's core to the design of T-format is the ability to layer. So what that means is you can take some formatting that already exists, take a table that already exists, and just add on a little bit of customization without going into that original program, without going into that, that first T-format object. So layer function, this layer T-format allows you to layer on a little bit of customization, and you can preserve the original formatting while adding on your own flavor to that table. So it was something there was no footnotes. I think, what else did I change? The column order I changed. I changed the title. So added some blank rows. So little things like that. And just I'm going to cover this a little bit in the coming slides, but what are the things that are possible with T-format? What types of, what elements of the table are you customizing? Well, remember, under the hood, the ARD is just raw values. So we're talking about rounding. We're talking about combining values together in the table, or formatting the big ends in the header, putting footnotes in the bottom, things like that. Really just the aesthetics for how your ARD is arranged in the table. Because remember, the ARD is agnostic to the display. So T-format really takes care of that piece of taking that ARD and arranging it and formatting it in the display. So with templates, what you can do is you can put, as an organization, you can disseminate standards really easily. So you can put, and I think this is sort of similar to what you were talking about with GT summary themes, Daniel, is templates in T-format. You can define all those super granular or broad elements of the table that, your standards for rounding, your standards for big ends, anything, footnotes. You can throw all of those in an organization level template. And so people can pick it up and just pass in their data and get a table with values really, really easily that meets the organizational standards. But oftentimes you have an organizational standard, but maybe your therapeutic area has a little bit of a different need or a different flavor on things. So you can create another template for your, say, therapeutic area that adds in your own little flavors. And again, you could just be customizing the bits that are specific to you, and you can layer on organization, therapeutic area, and then you have your custom table that's based on the organization standards from the beginning, but you're kind of layering on bits that are needed that are specific to your therapeutic area. Maybe your study has something also a little bit custom. So again, it's just going to kind of iterate, and you only need to define the pieces that you would like. You don't need to go and redefine the core broad elements of the formatting. You just get as granular as you need, layer that on, and it'll make that tweak as you go. So I think this is really important to remember about T-format is sort of metadata can be stored as organization level or department level, therapeutic area level standards and templates that people can pick up and use. And that means that everyone's kind of abiding by the standards and keeping things consistent. Because we are storing all the formatting as metadata, it can be saved out in a language agnostic format. Likewise, it can be created using whatever you'd like and then brought back into R. So T-format has this utility, T-format to JSON, that allows you to take your T-format object that contains all the formatting and export it to JSON file. And you see all of this formatting that probably doesn't mean much to you because it has some pretty specific terminology in here. But this all translates into the T-format formatting functionality. And again, you can load this back in later. And this can be stored just like any other data set or anything like that. because it uses GT, the T format can be saved through whatever mechanism GT allows. So that's really nice. All right, so formatting a display. I just want to give you a sense at what this process is like and what's possible. I won't be able to cover everything, but here's a look at our ARD. It's a little bit transformed, and I think I have a slide coming up of the cards output and how you get it. You take it one more step to get it to a display ready, but basically you just need to rearrange some of the consolidate some of the columns, but it's going to look like this: one record per unique value, and we have our treatment column. We have things kind of ready to go for the table. So T-format's arguments kind of split into two pieces. One is the data mappings. These are the data mappings right here that just say, you know, which column goes where, what column goes in the rows, what column goes in the columns, which of the values. And so you need to define these up front so that T-format, or at a minimum, so T-format knows where to put everything, right? And so it looks something like this. So here's our T-format function. I have specified what goes where from my ARD, and this is what it looks like by default. So generally it looks like, okay, the age, those are in the rows, that looks like what I want, and my treatments in the columns, that's good. But I have some extra bits. You see my order columns. They're being used to sort the table. And then I have some unformatted values. And so you just kind of continue this process of here I'm saying where to put the big ends. They were just floating in the bottom of the table. They're part of the ARD, but I want to put the big ends in the headers, so I can use that. T-format has a little bit of functionality to format those in the header. As far as rearranging columns, renaming columns, there's a column plan. I've dropped out the order columns. Another piece is the body plan. This is where I format values. And again, we don't have time to get into the details, but you can do all sorts of values, combining and adding characters like percentages and parentheses. So getting as granular as you need. And maybe it's that you have a labs table and everything looks the same and you can just define all your formatting at once. But what I'm doing here is I'm iterating. I'm getting more granular for specific values in the table, specific rows that need to be formatted differentially. I can do column alignment. It actually has, we have a lot of functionality for column alignment, which is made possible by making everything a monospace font. Adding footnotes, adding titles and subtitles, all of that can happen. And through this example, I'm doing these bit by bit, but you can specify all these things at once. There's other features as well, like pagination. And I have a little bit on cards to T format. I think generally it's true that the cards output might need a little bit of manipulation if it's going to go to a non-GT summary display, right? And so we have a function in cards called shuffle ARD, which basically takes the native cards output and does a little rearranging and consolidation of, say, group 1 and group 1 level, putting those into one column called treatment 01A. So we have a utility shuffle ARD that takes the cards and consolidates a little bit so that you have, one column per item that you would want to display. So shuffle ARD will be something that is useful to you if you're going from cards to T format. So I just want to point that out. And then this is essentially like a full example of the cards, the shuffle, and the table, the T format call to get it in your display here. So have a look at that after the workshop if you like. For new T-format users, we have a Shiny app called T-format Builder. This is just a point and click interface for T-format, and it makes it really easy to get to know T-format. It also makes it easy to customize existing tables. So it's helpful learning tool, but also just helpful for anyone who might want to make or modify tables, especially if they're less technical. So I had a little exercise that I'm just going to show you real quick instead of breaking out. Y'all can see my...
Do you know?
Okay, good. Okay, so T-format builder, it lives in its own package. So you would do library T-format builder, and this is in the 04 tables T-format file if you want to run it later. Load our libraries. I will need T-format for one of the functions. Basically, I need to pass in my ARD. And if I'm modifying an existing table, which I could create a table from scratch in the app, but I'm going to modify an existing one. So I'm going to load into my session the JSON file that contained all of my original demographics table. So remember, you can export the metadata to a JSON file. It can be reused later, and that's what I'm going to do. So I have my ARD, I have my prior T format, which was saved to a JSON, but I've loaded them back into my session. I'm going to pass them into my app, which is, it's got the function T format builder. I'm going to pass the T format, the ARD, and I'm going to set mock mode to false. So you can turn mock mode on. I think mock mode is the default. I'm turning it off because I want to create a table with values as opposed to a table without values, which is a mock. So I'm going to go ahead and run that app, and hopefully you can see my browser now. Yes?
We see it. We see it.
Okay, good. So this brings up the app. We can skip the initialize tab because this is where I've already put things in here through our, if I hadn't done that, you would see a little upload functionality. But here's my existing table metadata, already been loaded in, my ARD already been loaded in. So I can go over the edit tab. And this is where we see our table, this is our existing table. All of the different pieces that are available in the T-format package, as well as the app, are over here. These are all the different formatting aspects of the table. The first view is the data mapping. That's already been configured. That's good to go. So what I was going to have you do is adjust the column order. That can be done through the column plan. It's just a little click and drag. I'm going to rearrange those. Table. And we see the active and placebo are now reversed. Something else I was going to have you do is change these little footnote superscripts from numbers to letters. So I'm going to go to the footnote plan. That's where you can modify footnotes. And I'm going to switch that from numbers to letters. Refresh. We see letters. They're really tiny, but that is an A. And then the other thing I was going to have you do is split the table up. So to deal with anything pagination related, this is a single page table now, but I want to split it up into 2 pages just for the purpose of this demonstration, even though it's a small table. I would go to the page plan tab and set it, let's say, I think 3 rows as a maximum, refresh the table. It splits. I have page 1, page 2, and then I can, when I'm all done my customizations, there's more, feel free to explore them. I can go to the export tab, which is where I can both export my updated JSON metadata containing my new my updated specification as the table as whatever file I choose. So those, whatever's available in GT is here for you, that you can save it to your file type. So that is the app. So again, mock mode was off, but you can make mocks as well. And so it's really nice if you're learning for the first time or you're modifying an existing table. And we'll wrap up now because we are over. But this is what we covered today. Cards, card X, GT summary, T format. Hopefully now you have at least an impression of things and can understand at a high level how you might use them in your workflow, what they look like. But from here, we're going to skip slide up. Links to the repos and the websites for the respective packages. Please feel free to explore more. And the link to all these materials is available for you at the end or at the bottom here. So yeah, get in there and do some exercises that we were not able to spend a lot of time on. And Yeah, thank you all for coming. Thanks for your attention. We really, really appreciate it. And we're here to answer any questions if anyone's hanging on a little bit longer.
I just want to reiterate that what you said, Becca. It was wonderful prepping this together with Becca and Jack, and thanks for coming. And we're here for questions. And I love that this amazing ARD work is a big collaboration between Genentech, Roche, GSK, and Novartis. I think it's really, really wonderful place to be, and wonderful collaborators as well.